Hello everyone. We are going to be talking about node analysis today. Just want to make sure my mic is on, and it is on. Cool. So, node analysis. I'm going to be using this problem to explain how to complete node analysis. The question at hand is, what is VO? Okay. So we are solving for VO in units of volts, and we are going to be using node analysis to do so. Couple rules. First, we assume that the positive terminal is at the unknown node voltage. So positive terminal is at the unknown node voltage, okay, called VO. And the negative terminal is at ground. If it is not drawn for you, then that means you decide that that is ground, okay? And so this is my ground. That's 0 volts. This is my VO. All right. Second, label all known node voltages. How do we do that? Well, we have to start analyzing and understanding where are the nodes. So this is a node. It is connecting the 2-volt source, the 1000 ohm resistor, the 500 ohm resistor, and the 10-volt source. Because that is one big node, I can assume that this is also 0 volts, this is our 0 volts, this is also 0 volts. I also then notice that this is a node. I also notice that this is a node, and I notice that this is a node. So for the one that I just erased, if I start from 0 volts and I go up the 2-volt source, this is 2 volts. This is 2 volts because it's the same node. If I start at the 0 volts and I go up the 10 volts, then that means this is 10 volts and this is 10 volts. And VO is the unknown voltage. The VO is the unknown node voltage. Okay? Third step. Set a current going from the positive terminal of the unknown node voltage to the negative terminal. So that is this one. Call it IO. Okay? And then you set all your other currents affiliated with this node. You assume that it's going into the unknown node voltage. So this one, call it I1. This one going in, call this I2. This one going in, call it I3. Let's redraw I1 because it's going over our numbers. I1. So I1 is going down 200 ohms. I2 is going down 400 ohms. And I3 is going, let's say, up the 500 ohm. All right. I'm just using these up downs with respect to my typical north, south, east, west. Okay, so label all known node voltages going back. 3. Assign currents at unknown node. At unknown node. So current leaving node towards ground. When I say node, I'm talking about the unknown node. Okay, so current leaving, let's just start creating acronyms. UN, unknown node. So current leaving UN towards ground, that's one of them. All others going into unknown node. Okay, that's what's going on. Step number 4. Step number 4 is set all complete KCL at the unknown node voltage. So step number 4, complete KCL at unknown node. Unknown node. which is VO for us. Okay, so let's comma using eyes. Okay, we could do that. Just zoom in a little bit. KCL states that the current going in is equal to the summation of currents going out of a node. So using lowercase i's, that would be what currents are going in. That's I1 plus I2 plus I3 equals which one's going out? IO. Step number 5. Use Vx minus Vy over R alpha notation to substitute for your eyes. Okay? Brief explanation using Ohm's law. Plus minus VR, current going down. Using Ohm's law, in this notation, VR is equal to IR times R. Electrical engineers in this drawing we assume that V positive terminal is greater than the V minus terminal. Let's give it some names, A and B. So we assume VA is lowercase a is greater than VB. Kyla, chill out. Because we assume VA is greater than VB, we are going to state then that VR is equal to VA minus VB. Sorry, I have a dog. Which is then equal to IR times R, which means IR is equal to VA minus VB divided by R, which means in this specific class scenario, for who knows what reason, we are saying that V initial minus V final over R is equal to IR. Okay, so using this notation, V initial minus V final over R is equal to IR, replace the currents. So we come back here. This is our KCL equation. So I am going to take it. I'm going to come down here. I'm gonna put it right there. So we are continuing. What is I1? Well, I1 is V initial minus V final. 2 volts minus VO. 2 volts initial minus final, VO, divided by 200 ohms. 2 volts minus 0 volts minus VO divided by 200 ohms. What about I2? I2 is going from 10 volts to VO over 400 ohms. 10 volts to VO divided by 400 ohms. What about I3? I3 is going into VO from 0 to VO. 0 volts minus VO divided by how many ohms? 500. This is all equal to I0, which is going from VO to ground, which is 0 volts. You can refer to your drawing in your notes. You know what? Let me just show you. IO in red is going from VO to 0 volts over 1,000 ohms. In this equation, you have one equation and you have one unknown called VO. You can solve for VO. If you solve for it using high school level algebra, you will see that VO is equal to 3.33333 volts. We have successfully learned, hopefully, the node analysis. Okay, now let's use it for a specific problem. I'm going to call this example number 2-9-3 for any random reason that would float your boat. Okay. R2, R1, Vs, and we are told that it's minus plus V2. Okay. And we are told that Vs is equal to 8 volts, Is is equal to 10 milliamps, R1 is equal to 100 ohms, R2 is equal to 300 ohms, R3 is equal to 300 ohms, and R4 is equal to 600 ohms. So, again, this is example problem 293. So, with that being said, I would like to know, question, what is V2? Let's do the steps all the way starting here. Okay, you know what, that's not an efficient use of my space. Let's just do it here. Steps, as we mentioned previously. Label the terminals of the unknown node voltage. They're already provided for us, positive and minus, okay? Step 2, or I guess that's part of step 1. Set the negative terminal as ground. That's part of step 1. So I'm going to draw that. This is ground. This is 0 volts. This right here is a node. So this is also 0 volts. Step number 2, label all possible known voltages. If this is my ground and I go up Vs, this is now my Vs. This whole thing is a node. So this is also Vs, this is also Vs, this is also Vs, this is also Vs. Okay? What about here? This is a node. So this would be V2, V2, V2. Okay? What's step 3? Assign current and at unknown node called UN, right? Current leaving unknown node voltage towards ground, that has to be drawn, and all other currents are going into the unknown node. However, you keep current and direction of current source as is. So what do I mean by that? If you come down, you see you have a current source, IS. It's leaving node V2. So I'm going to leave it at that. Just going to reiterate that this is IS. Okay? So I have to draw the current that's going from the positive to the ground or to the negative terminal. That is going to be drawn with purple. Call this I2. All others are going away, are going to V2. I3, I4. Again, reiterating step number 3, assign current at the unknown node. So the unknown node is V2, but you have to make one current go from V2, the unknown node, to ground. That's in purple. The red, I3, is going towards V2. I4 is going towards V2. Current sources must be left as is. So that's why IS is going up, because that's the way the current source is originally going. Step number 4 is complete KCL at unknown node. So we're solving for V2 in units of volts. So KCL at node V2 is going to look like what? Summation of currents going into a node is equal to summation of currents going out a node. So what's going in? I3 plus I4, this is a plus, is equal to I2 plus IS. Okay? Now replace these currents with the voltage initial minus voltage final divided by resistance. What am I talking about? I'm talking about this notation that was discussed here. So, looking at our circuit and zooming out. Okay, we're going to move up here now. What's I3? I3 is initial minus final, Vs minus V2 over R3, plus initial minus final over R4, equal to, what's I2? Initial V2 minus final, 0 volts, over R2 plus Is. Again, it's V initial minus V final over R equal to I for node analysis. Okay? So we look at this equation, this one. How many unknowns do we have? One. It's just V2. We know Vs, we know R3, we know R4, we know R2, we know Is. Solve for V2. And if you solve for it correctly, you will get that V2 is equal to 3 volts. Okay? Boom. I have shown node analysis here twice now. I am not going to do the high school level algebra because, one, I don't have time since I've had issues uploading these videos numerous times today, and because I believe you can do it. But I am providing the answer that you should be getting. So the math up to the node analysis part is complete. After that, it's just high school level algebra. Okay? Thank you for joining.